Hi, my name is Andrew McCullough, and I'm going to show you how to solve an exponential word problem using the equation f of x is equal to x to the n. In this particular question, it's sort of asking you to use your equation to find the instantaneous rate of change, which is the IROC, at a certain time. So, we have our question right here. Our question 9, right here. It's saying the population of a town is decreasing at a rate of 1.8% annually, and the current population of the town is 12,000. So that is all shown right here. So that's our first question. So part A of the question is asking you to write an equation that models the population of the town. So, using what we already know, we are going to use the equation f of x is equal to n to the x. So we're going to use that to solve for part A. Part A is saying write an equation that models the population of the town. So, what we already know. We know that the current population of the town, which is our initial value, is 12,000. And we also know that our rate of decrease, so the rate at which people are leaving the town, so rate of decrease is equal to 1.8% annually. Now, we can't keep it in percents, we need to move that to a number that we can work with. So, to change your rate of decrease, which is 1.8%, into a number, all you do is you subtract 1 minus the percent. 1.8% is equivalent to 0.018. So you do 1 minus that, which gives you an answer of 0.982. Alright, so now that we have that, we can set up our equation, but we're not going to solve yet. We're going to walk through the rest of the question. Part B is saying estimate the instantaneous rate of change in the population 10 years from now. Let me highlight that for you. Part B there. So, one thing you need to focus on in this question is that you make sure that you're using IROC, which is the instantaneous rate of change. You don't want to use AROC. If you get those confused, you're going to get two completely different answers. IROC is the rate of change at a certain point. AROC is the average rate of change between a certain time period. So, with part A, so that's part A and part B. Now for part C says determine the instantaneous rate of change when the population is half of its current population. Right there, so part C. Part C is the same, make sure you're using IROC, not AROC. Also, it says determine the instantaneous rate of change when the population is half of its current population. So knowing that, it gives you our y value, because y, or f of x, is equal to, so if it's set up like this, our equation, f of x is equal to n to the x. We have our y value in part C, it gave us that. So we know that 6,000 is equal to n to the x. So, now that I've broken down each question for you, we can get started. So to solve question A, we're going to be using the form f of x is equal to n to the x. So with that, that's the equation that we're going to be using in this certain question. So what we need to do is we need to find out what we have already. So what we have already is our initial value. Because if you remember from the question, it says the population of the town is currently 12,000. So that's going to be our initial value. 12,000. Now we also have a rate of decrease in this question. In this case, the rate of decrease is equal to 1.8% annually. Now Now, we don't want to leave this in a percent value because you can't do anything with that. What you need to do is you need to take this 1.8% and make it into a decimal. So we know that 1.8% is equal to 0.018, right? So now what you need to do is, because you know that your rate is decreasing, so you want to take your town, you know that the population of your town is decreasing. So you know that you can't multiply your initial value by something greater than 1. If you do that, then your population is going to be increasing. So what you do is you take 1 and you subtract your percent from it right here. So 1 minus 0.018. Once you have that, your answer is 0.982. Now that we have everything that we need to set up our equation, now let's write it out. So f of x is equal n to the x, right? We know that our initial value is 12,000. So let's make sure to put these in brackets, not to confuse yourself. So you do 12,000, which is your initial value, multiplied by your rate is 0.982, all to the exponent x. Now we're trying to solve for x because x is the time period, or the certain time, and we don't know what the time is because all we're given is the rate of decrease and the population. So basically, x is our variable right now. So there's part A done. Okay, so now that we're done part A and we have our equation right up here, we can use that equation to do questions B and C. Question B states, estimate the IROC 10 years from now. IROC being instantaneous rate of change. So we know that our x value in our original equation is the time period, and in this question we are given the time period, 10 years. Now, to find the rate of change means that you need to find the slope. To find the slope of a line at a certain point, you need to use the equation y2 minus y1 over x2 minus x1. Now in this certain question, if we plug 10 into our x value, we'll be given one x value and one y value. Now as you can see, to find the IROC, you need two y values and two x values. So what we do is you take your x value and you add and subtract 0.001 from it. So you're going to get two different answers. You're going to get 10.001 and 9.999. Now we do this because these values, as you can see, are obviously very close to 10, and it's going to give us two x values and two y values if we plug each of these back into the equation. So doing that, you're going to get your y1, y2, x2, x1, and then you can plug those numbers into your slope or your equation here, and then you're going to find your IROC. So let's do that. So we have our first question. Well, let's use this one first, 10.001. So that is going to be our x1. This is 9.999. It's going to be our x2. Now whatever values we find while plugging these into the x equation are going to be our y1 and y2. So let's do that. So if we have f of x is equal to 12,000 times 0.982 to the exponent 10.001. You solve for that. Now let's remember BEDMAS, brackets, exponents. So you can see that there's nothing to solve within the exponents, so you want to go, within the brackets, so you want to go straight to the exponent. You want to do 0.982 to the exponent 10.001. That is going to give you a value. We'll call that value b for now. So the next part of your equation, you're left with 12,000 times b, b equaling 0.982 to the 10.001. After that, you get an answer multiplying 12,000 times the product of the 0.982 to the exponent 10.001. So your final answer from that should give you 10,006 decimal 0.63907. So now that we have this value, that can be our y1. So this is our f of x. So 10,006.63907 equals y1. And remember that we already have our x1, which is up here in the top right corner of our x value of our first equation. So 10.001 is equal to x1. Now we need to find our y2 and x2. We do that by plugging in our 9.999 into our original equation up at the top here. So now that we do that, we have our next equation. I'll change colors for you so you're not mixed up. F of x, we're still using the same equation, 12,000 times 0.982. All we're doing is plugging in a different x value, 9.999. So once we do that, again, remember bed mass, we're going to do 0.982 to the exponent of 9.999 first. And that is going to give you our b value again. And then you multiply 12,000 times your b value. And in this scenario, you are given 10,007.0026. So this is also equal to f of x. So now we have our y2 value, 10,007.0026 is equal to y2, and our x2, which is our value that we just plugged in, 9.999 equals x2. There we go. So now that we have our x2, x1, y2, y1, we can now solve for the slope of the line, or the IROC, at 10 years from now. So let's just erase this and solve. So we have y2 minus y1 over x2 minus x1. So that is equal to, so we take our y2 value from down here, right there. So we do 10,007.0026, subtract our y1 value, which is right up here, 10,006.63907. Let me just fix this up for you. And then you plug in your x2 and your x1. So we know our x2 value right here, 9.999, minus our x1 value, which is right there, 10.001. Now, we know that the population of the town is decreasing. So the slope of the line at this certain point should be a negative number. So if you figure out what your numerator equals, you're going to get a positive number. So in this case, it is 0.36353165. Now you want to keep all those decimals. You don't want to round off too quickly, or else your answer is going to be inaccurate. Now your bottom number is going to give you a negative, which is perfect, because a positive divided by a negative is going to give us a negative number, and that's what we need. We need a negative number because in application to the question, that also means that a negative number means that there are people leaving the town. And that is perfect because our question is saying the population of the town is decreasing. So we're set up for success right now. So we know that the bottom, or the denominator, is equal to negative 0.002. So once you have that, you just divide your answer. You just divide, and you get your answer of negative 181.77. So that is our final answer. But you can't leave it like that. You need to write a statement at the end that applies this answer to the question. So the question says the population of the town is decreasing at a rate of 1.8%, and the current population of the town is 12,000. Now we need to estimate the IROC at the population 10 years from now. 10 years from then. So now we're dealing with the 10 years, and we found this answer. So now we just need to write out our statement, which is at 10 years from now. 10 years from now, there will be 181 people leaving the town. And that concludes part B to this question.